In this video, let's talk about my 10 gigabit home network. This is the first rack in my server room. You can see a lot of UniFi switches. Most of them support 10 gigabit Ethernet. In the second rack, I mount several servers to run virtual machines and some of my non-UniFi switches. And then I have multiple switches in different rooms. They are all connected to the server room. There will be 3 parts in this video. First, 10 gigabit home network cabling. Then let's talk about network topology. The last part is about how to connect your devices to 10 gigabit switch. SFP Plus is a very commonly used interface type in 10 gigabit switch and network interface card. Normally, they are much cheaper than the RJ45 devices, but to utilize them, you need corresponding cables or interface modules. Since SFP Plus is the most common part you can find in your 10 gigabit switch, let's talk about how you can connect your cables to the switch. Here you see 3 different interfaces. This one is for fiber cable. So here you plug in your fiber cable plug. This part you plug into your SFP Plus port. And this one is for normal Ethernet cable with the RJ45 connector. And this one is the DAC cable. It's already pre-connected to your copper cable. And if you check the other side, the SFP Plus side, they are the same. So normally this RJ45 ones, it will cost you about $50 to $100. And the fiber one is a little bit cheaper. And the DAC cable one is the cheapest. You may use 3 types of connections in your home 10 gigabit network. The first one is DAC cable. DAC stands for direct attach copper. It's very strong, very affordable, and very easy to use type of cable, but it has its own shortcomings. We will talk about that. And in the middle, you see the fiber cable. It can connect your devices even if they are very far away. And the third one is our familiar RJ45 Ethernet cable. Okay, first, DAC cable. This is my favorite type of connection. It's relatively cheap. If your switch has the SFP Plus type of connection, you don't need any additional modules. You directly buy a DAC cable, you are done. The problem is it's not very long. I only use DAC cable in my server room to connect different switches. Fiber, yes, the fiber itself is not expensive at all. If you search Amazon for 10 gigabits, you can buy 50 meters, 100 meters at a very, very affordable price. The problem is it's very fragile because it's fiber, right? If you do not pay attention, it may break very easily. And once it's broken, as a home user, you have no way to repair it. You don't have the proper tools. It's not worth it to repair it. So basically, you throw it away. Not like Ethernet cable. If it's broken, you cut it, you can still reuse the remaining part. No, it's not the case for fiber. That's something you need to be aware of. RJ45 Ethernet cable, I simply buy very cheap, very long patch cable, cut them to the sizes I need, and then made the cable by myself. When it comes to 10 gigabit cable, people always worry about the categories, the grade of the cables. To be honest, in my case, I never care about the categories. I simply use the cheapest patch cable. I believe it's category 5E, but because I only use them in short length, I've never noticed any problem when it comes to 10 gigabit switch. They always work. I'm not saying the category or grade of Ethernet cable is not important. I'm just saying in my case, for my usage, I don't really care. This is the network topology display from UniFi Network Controller. You can see it doesn't have the router displayed because I use pfSense. It's not managed by the network controller. The starting point is USW Enterprise XG24. It's connected with the Pro aggregation. You can see it really aggregates a lot of other 10 gigabit switches. Some of them are USW aggregation from other rooms. Some of them are mounted in the same server room rack. This room is special. It's furtherly connected with another flexible 10 gigabit switch from UniFi. Okay, now let's look into the details. I have the devices spreaded in multiple rooms. Here I use the word room, but maybe it's just a closet or a desk. Here in the diagram, I mentioned totally 7 rooms. In the server room, I have 2 racks. One rack is mainly for UniFi devices, the other one for my home lab servers. In my backbone network part, the first device, the very important device, is the router. Even though I have many UniFi devices, for router, I use pfSense. So I have a rack mount server running pfSense. If you are interested, check one of my videos about how I built this pfSense box. The pfSense server has totally 6 10 gigabits ports in RJ45 format. I use one of them, connect to internet, and then for remaining 5, I connect all of them to the UniFi USW Enterprise XG24 switch, and then I configure link aggregation. So in total, my home network has 50 gigabits uplink to the router. You may ask, do you have 50 gigabits internet? Of course not. But remember, the router is not just for internet. It's also for, let's say, inter-VLAN routing. So I need more than 10 gigabits throughput. That's why I use link aggregation here. This is my first UniFi switch. I connected to another 10 gigabits switch, the USW Pro aggregation. The Pro aggregation has 4 25 gigabits ports. So I use 2 of them connect to the USW Enterprise XG. So in total, I have 50 gigabits here as well. USW Pro aggregation is the real aggregation switch because as you can see, almost all other switches are connected to this particular switch. I have a 48 ports PoE switch. Of course, for the 48 ports, they are just 1 gigabit ports, but it does have 4 10 gigabits SFP plus ports. You can use them for other usage. I use them all for uplink, so I configure link aggregation. In total, 40 gigabits uplink here. For this USW Enterprise 24 PoE switch, similar case, I have 20 gigabits. For this 24 ports normal switch, I have 20 gigabits uplink as well. As you can see, I use link aggregation extensively. If you are interested, check my another video in the channel. This is my backbone network. Check the right part. So I have 6 separate rooms. For each room, it has its own 10 gigabit switch, but it's cheaper with less ports, the USW aggregation. It has only 8 ports, enough for each room's usage. The rooms are separate, so I cannot simply link the switches back to my backbone using DAC cable. I want to avoid the troubles of RJ45, so I use fiber. From each room, I run a fiber cable link back to the server room to this particular USW Pro aggregation switch. And for the first 5 rooms, I run additional 1 gigabit Ethernet cable linked to the mini USW switch just to connect the devices which don't really require 10 gigabits. For the very last room, I need additional 10 gigabits ports. That's why I use a separate USW Flex XG. This switch has 4 10 gigabits RJ45 ports, so I connected to the USW aggregation. And then to the left side, this is the part for non-UniFi switches. I do have 100 gigabits switch, but it's just for my home lab, and I don't use it as a part of my back backbone network. Because this one is 100 gigabits, it exceeded the ability of my backbone network. So I run 2 breakout cables. Each one break out to 4 10 gigabits. So in total, I have 80 gigabits. I configure them as link aggregation. So my home lab has 80 gigabits uplink. Check the dedicated video in my channel about 100 gigabit home lab cabling. And then I have other switches, for example, MikroTik ones. They are either RJ45 or SFP plus 10 gigabit switch. For example, for this one, the first one, it does have 40 gigabits port. And for the other MikroTik switch, I simply run the DAC cable and configure link aggregation. Inside my home lab, I do have several UniFi routers. Even though I don't use them in the backbone network, I connect them using DAC cable to the USW Pro aggregation, and they all have the 10 gigabits WAN link. And then, of course, separately, I have UniFi Protect surveillance system, and I use UNVR Pro. It also has the 10 gigabits uplink. I connect it to my backbone network. Here you can see the legends. I use different type of cables. They support different speeds. For most people who are interested in 10 gigabits switch, normally they already have 1 gigabit home network. Then they have devices which have the potentials to support higher speed. They are wondering how they can enable the higher speed. Depending on different devices, you have different ways to hook them up to the 10 gigabit network. Here I listed 4 different ways for my home network. First one, you have a laptop. It has a Thunderbolt port. You can buy a converter or adapter from Thunderbolt to 10 gigabits RJ45. As long as you have the RJ45 port, you can run normal Ethernet cable, connect to your switch. If you are lucky, your switch has RJ45 port as well, you are done. That's the easiest way to enable the 10 gigabit. Of course, similarly, if your network interface cards have the RJ45 ports as well, basically it works the same way. Okay, move on to the second one. This one is the cheapest way and my favorite way to connect device to 10 gigabits network. Your computer or your NAS has PCIe ports. You can buy very affordable 10 gigabit network interface cards with the SFP plus port. Keep in mind, if you have 2 network interface cards from the same manufacturer using similar chips, just because one has RJ45 port, the other one has SFP plus port, their prices are dramatically different. The SFP port ones are much cheaper. Okay, so you have PCIe, you buy a SFP plus network interface card. Your switch also has the SFP plus port in most cases. Then you simply buy a DAC cable. You are done. This type of connection only works if your device is not too far away from your switch. Normally, they are in the same room. Move on to the third approach. Similarly, you have a device with Thunderbolt, but your switch doesn't have RJ45. It only has SFP plus port. It's very easy. You just need one extra thing: 10 gigabits SFP plus module, a transceiver to convert from SFP plus to RJ45. Move on to the very last one. In your client side, you have SFP plus, but in your switch side, you have RJ45. To be honest, this type of connection is not very common. Similarly to the third way, you need a module to convert from SFP plus to RJ45, but you use the module in the client side. So these are the 4 different ways I use in my home network to connect clients to switch. Another type of connection is between your switches. You may not just have one switch, you have multiple ones. If they are all 10 gigabits, how you can connect them? In my home network, I use 4 different ways. The first one is the less common one. So you are lucky for both switch, you have RJ45 connections, simply use the normal Ethernet cable. And the second one, that's the most common way, and that's the cheapest way. For both of your switches, they have SFP plus ports. You simply run cheap DAC cable to connect them. The third one, that's the way I use to connect to my RJ45 10 gigabits switch to the SFP plus 10 gigabits switch. So basically you need additional module to do the conversion. In the middle, you simply run the normal Ethernet cable. The very last approach is the one I use to connect remote switch. In my case, it's a switch in another room back to the server room. Because of the long instance, I cannot run DAC cable, and I want to avoid the troubles of RJ45 modules, so I don't want to use Ethernet cable, so I choose fiber cables. To enable the connection, you need to use another type of transceiver. This type of transceiver is a little bit cheaper than the RJ45 one. It's very difficult to discuss everything in a short video. So if you have any comments or questions, let's discuss in the comment area. Thank you.